In this video, I'm going to talk about chapter 11 in our textbook, which is on inheritance and composition. Okay, so we covered some of this in class, but I wanted to tie up some loose ends and show some other code. Okay, so with inheritance, again, we're talking about an is-a relationship. So the example we're going to use is that a box is a rectangle. Okay, we're taking the length and the width of a rectangle. We're adding in the height to give it a third dimension. Okay. So we'll also talk a little bit about composition or aggregation, which is a has-a relationship. Okay, so a car has an engine. A car is not an engine. Okay, but a poodle is a dog, for example. So that's kind of how we're looking at these things. Okay, so I'm going to go ahead and share the screen with some code here. So the way the book, the example the book uses is the rectangle example, and this is available in the /TMP or the temporary directory if you need to look at it further. Okay, so we start with this rectangle class. Okay, in fact, actually, let me start looking at a UML diagram. That's probably the easier way to go. Okay, so here's our UML diagram here. Okay, so we see that our rectangle type is going to have two doubles, one for length, one for width. It's going to have a constructor. Okay, it doesn't have a default constructor. It could. I think the book has one, but I didn't put that in. We have our accessors for get length and get width, which return a double. We have an area, which calculates the area, returns that. We have a perimeter function, which returns a double. And we have a print function. Okay. And I think, I'm trying to think if it's in both places. There's a set dimension. I want to say that the book put in the box type that should be in the other one as well, but so we'll roll with that. So we also have here in our box type then. So this is what it looks like. It's an open triangle. That means inherits from the box type. Sorry, box type inherits from rectangle type. The arrow goes to the parent or the base class. This is the derived class. Okay, we're adding a new member data called height. It's a double. That's private also. Okay. Then we have the constructor, which takes a double, double, double. We have the get height, the accessor for the height. Notice there are no mutators. We're not allowing the user to change these. The set dimension does that, but for whatever reason, it didn't end up on this diagram. So we'll go from there. There's also a volume, and instead of an area, we're doing a surface area, and then another print function. Okay, so a couple of things here. When we're doing the inheritance, it can be a public, protected, or private. We've only talked about public. This all relates to the public information, okay, in all of those cases. So it doesn't matter in this cases that the private data is private, okay? So in the box type, in the functions I'm writing, I can't directly get to this, okay? So I have to use these public functions to get to them. Seems a little weird, but that's how it works, okay? So one other thing that we'll see is that because a box type is a rectangle, if there's a function or something else that takes a rectangle, it also takes a box because a box is a rectangle. It doesn't work the other way around. If you create a function that takes a box, it may not necessarily take a rectangle because a box is not a rectangle. No, that's correct. The other way around. A box is a rectangle. So if it expects a rectangle, you can give it a box. A rectangle is not a box. So a function expects a box. You can't make that substitution. Okay. Okay, so let's take a look at the code here. So here's the rectangle, and it goes through, and there's a set dimension. I just didn't put it in my diagram. Okay, so we start, I'm including IOStream because of the print function. Same thing, the using namespace standard, that's why it's there. Then in private, I have a length and a width. Okay, then I'm doing the set dimension, the get length, get width, area, perimeter, I didn't put there either, and print, which just prints out the length and the width. Okay. Notice it puts it on one line with a semicolon in between it. Okay. And then the constructor just uses that set dimension in this case to set the length and the width. Okay. It has a default constructor here with length and a width of 0. Okay. So then when we're looking at the box type, it includes the IOStream. It also includes the rectangle type, just so we know what, so it's there, so we can pull from it. Okay. And we're doing our class box type, colon, we're doing public. We'll talk a bit and what that means. Rectangle type here. Okay. Then we have our set dimension, which is going to call, this call is to the rectangle type. Okay. And I don't think that's necessary because I don't do it anywhere else. It's okay that it's there, but since I'm not using a header file, it should be okay. So I'm going to set the dimension there. This deals with the length and the width. That calls the parent version of set dimension. It adds in the height. Okay. The get height is new, so we have to add one. So it's there. The area, we're going to rewrite this one. We're going to overwrite the area. And if it's a box type, it will call this version of area. If it is a rectangle type, it'll call the other. Okay. But I'm just going to use, I can't get to the length and width directly. Okay. So I'm going to go ahead and do it this way. This just is going to calculate the 3 parts for half of the rectangle of the box, and then multiply by 2 to get the total surface area. And then here's the volume. Okay. Then here's the print. Print's also defaulted to that, which I don't think we need. Okay. Oh, we may there actually. Because it's the same name, that's why it's there. Yeah, that may be the same issue there too. Which one had the same name? Area doesn't call area. Get length is not. Yeah, that's why we need it. It is there because it's the same exact name. We have to specifically call the rectangle type version. Okay. If not, we'd be confused which one we're talking about. Okay. So it's not recursive. It's not calling itself. It's calling the parent version of that. Okay. And here's the constructor. The other weird thing here, again, we can't create the rectangle type that we need to directly. We're going to call the rectangle constructor here. And then we're left just with the height. Okay. As far as what this looks like when you use it. And again, all these are in the temp directory. I'm just including the box type.cpp. Okay, I don't have to worry about including the rectangle type because box type has that already. Okay. And then we're using namespace standard here because we're going to print out some stuff. So I'm then declaring my new box type here with 1 as the length, 3 as the width, and 4 as the height. It will then call automatically, because that's how we set it up. It will call the base class, the rectangle constructor, to make a rectangle of length 1 width 3. It then will deal with the height there. Okay. I can then call this version of the area program and also the volume to get those pieces of information. Okay. So one thing we haven't talked about yet in class, I don't think, but we need to, is the idea of destructors. Okay. So the constructor function is just the name of the object. Okay. You put a tilde in front of it, it becomes a destructor. Okay. And the destructors, if you would have a box type, when it goes out, and it would destroy any dynamic memory, which we'll talk about later, for itself, and then for the rectangle that it created as well. Okay. That's all we need to know about that. Okay. So let's talk about these options that we're making here by making it a public inheritance. Okay. So if it's public inheritance, let me see, I've got a list of all the facts and figures here. Yeah, so if this is the member access specifier. So on that line where we're declaring it to be declaring the inheritance, if it's public, then the public members of the super class or the base class are public members of B. Okay. The protected members, protected are kind of in between. Okay. Protected members of A are protected members of the base class are protected members of the derived class. Okay. The private are hidden no matter what. Okay. If we say that as protected instead of public, okay, then the public members of the base class are protected members of the derived class. So not as much accessibility. Protected are still protected, private are still private. Okay. If we say private, then everything is private. Everything is hidden. Okay. So yeah, we typically just make them public, but sometimes there are reasons not to. Okay. So the other kind of thing that we can do in addition to composition, and we'll just mention it briefly here, I think I've got an example of it, is going to be composition. Okay. Do I have composition somewhere? Looks like I do not. I had one, now it's gone. Okay, anyway, with composition with your UML diagrams, that's the HAZA. Okay, so an engine or car has an engine. Okay, with that, we're going to use a black diamond to connect them. Okay, and composition, you don't make any changes to the element. When you design a class, or we design a car class, we can put any member data that we want, including an instance of the engine class or an instance of the wheel class or whatever you have. Okay, so when you're doing composition, you're just going to use the member, an instance of one class as member data in your new class. Okay, and nothing else really happens there. It's all pretty straightforward from there. Okay, so what we're going to talk about more on Monday, let's do some exercises here, is we up until we hit classes, we were doing what's called structured programming. We're now doing object-oriented design or object-oriented programming. Okay, so there are some terms there that we need to know. I'm going to go ahead and share a screen here so we can write these down. Okay, give us some room here. Let's do a new page. That'll work. Okay, so the first term that we use, and again, these are the basic principles of object-oriented design. Okay, so the first we have, make it a little bit bigger. First we have encapsulation. Okay, so encapsulation is the ability to combine data and operations into a single unit. That's what our class does. Okay, our class has data and it has operations. Okay, the next one is going to be inheritance. We talked about inheritance. It's the ability to create new objects from existing objects. Okay, and then we have polymorphism. Polymorphism is the ability to use the same expression to denote different operations. Okay, so we can use something like the plus sign could be overloaded to have different kinds of functionality depending on what you're adding together. Okay, so that's basically the idea of that. Okay, when it comes to designing a class, no one in the world is likely to give you a UML diagram. They're going to give you a bunch of words. Okay, so the book gives some advice here that you look at a description of the problems, the problem you're trying to solve. Someone tells you, you ask them you ask them what do they want, and they write it down in words. Okay, you're going to go through and identify the nouns. The nouns are potential classes or potential objects, and then the verbs become. Sorry, the nouns are the potential member data, the things that you need to know, okay, about it. And the verbs then are the methods that it needs to do. Okay, so not all, some you can get rid of, but the book gives an example where it goes through and helps us to figure out what characteristics about the object we care about. Okay, so what we need to know. What does a class need to know? What does a car need to know about itself for your particular program? It may need to know its speed, its direction, its color, its model, its make, whatever. Okay, and then what can it do? Become the verbs become those. What can you do? And those are either operations that the object can perform. They're operations that can be performed on the object. Okay, and those are the two kinds of operations that we have to worry about. Okay. So this is not 100% correct. And I mean, it doesn't work all the time, but by going through and looking at those problems, you get an idea of what to track and what not. Some are redundant, some you don't need. So you just have to make that decision. But that's how you start, the nouns and the verbs. The nouns become the member data, the verbs become the member functions or operations. Okay. So that should get us going through chapter 11. Okay, again, we'll do another in-class exercise on Monday to reiterate that. Continue to work on your cylinder and your circle programs. I have uploaded again to the temp directory the box and rectangle, which should be similar. It should help you be able to pull that together. Okay. If you have any questions, as always,